Thank you so much, Scott. And I'm super excited to welcome you all to yet another edition of the talks by the GDG AI for Science. Thank you so much to all of you for making out the time to do this. We are going to have a really exciting discussion about LLMs and then what they can do for science. But before we get into that, just wanted to let you all know, who are the groups represented on this call. So on the one hand, we have the GDG community. So GDG stands for Google Developer Groups. And this is an external community of scientists and researchers in Australia, led by our intrepid organizers, some of whom are on the call. So Pablo, Susan, Marcel, and Leafy, who have helped us bring together this community of scientists and researchers in Australia who are interested in learning about AI for science and how Google tools can be used to deploy AI for different kinds of scientific workloads. On the other hand, we also have an internal community of Googlers who are very passionate about science, who are working on different technologies and different products that can be helpful to scientists and researchers. And that's the whole point of this initiative, this event. We are trying to bring scientists and technologists together to think about the beneficial adoption of AI in science and how we can all work together to make sure that this happens in the right kind of way. Next slide, please. And the main way in which we try promoting the sharing of ideas and in bringing people together around these topics is by organizing talks like this one. So if you go to the GDG chapter page, you will see a list of our upcoming events, and I would highly encourage all of you to sign up for these events if they're of interest to you. There'll be many more added to this in the coming days and weeks. Next slide, please. I, for one, am super excited about this session. I think we have managed to pull together a really expert panel of people from CSIRO and from Google. The topic of the discussion today would be around LLMs and what they can do for science. I know there's a lot of news and a lot of publications and a lot of research happening around the deployment of LLMs in scientific workflows. But in this talk, we will do a systematic overview of what these LLM models are capable of, how can they be safely and beneficially deployed for science, and what are the areas where they can truly prove useful for the work that scientists and researchers are doing. I will let the speakers introduce themselves when we get to their sections. And finally, next slide. Given that we have a lot of content to cover today, we will not be taking questions and answers during the talks, but we will have some time at the end to take questions. If you have any questions that you would like to submit based on the speaker sessions, you'll see on your bottom right, there's this button, which is called the Activities button. If you click that, it will take you into Q&A. And that's where you can add your question, as well as vote on questions that others have added. And at the end of the call, we will take those questions which get the highest votes. So with that, it's my pleasure to pass it over to our first speaker, Dr. Stefan Harrer. I'll let Stefan introduce himself and switch over to his slides.
Thanks a lot, Astitva. And welcome, everyone, to this session. My name is Stefan Harrer. I'm the director of CSIRO's AI for Science program. I'm joined by my colleagues Qinghua Lu and Sarnas Karimi, who will also present later in the session. CSIRO is Australia's national science agency. We are in the fortunate situation that we are in a partnership with our colleagues here from Google, a partnership that seeks to bring the powers of AI to scientists. That's really what it comes down to. As Astitva has just mentioned, LLMs and generative AI in general has brought a new kind of scale to what we can do by bringing AI into the hands of scientists. And this is what we'll be showing you some examples and talk to you about and hopefully discuss with you throughout this talk and at the very end. Next slide, please. Before we dive into it, I would like to begin by acknowledging the Ngunnawal and Wurundjeri Woi-wurrung and Bunurong Boon-wurrung peoples of the Kulin land that we are meeting on today, and pay my respect to their elders, past and present. Next slide, please. So, why are we here today, right? There are a couple principal goals that we can accomplish by commoditizing AI for scientific use. And this can actually transform how we do science. I'll talk to it in a little more detail later down the road. Think of AI as the virtual lab assistants that you can enlist to help with your discovery, your scientific discovery work as researchers. Of course, we need to do this in a safe, responsible, and trustworthy way. So how we design these assistants, how we use them, how we employ them, what we do with their outputs are all very critical and crucial points that we will address. And we will go into some details, such as, for example, summarization of material, and then looking at the quality, the accuracy of these summaries, and some other tasks that come in very often our way when we are working as scientists in the lab. Okay, next slide, please. And the next one. All right, so generative AI has been out there for a while. Why are we having this talk now? The reason is that there has been an actual growth spurt and scale spurt in what AI is able to accomplish and how we as users, how scientists can actually accomplish it. It started with what I call the bespoke chatbot revolution. You saw this when the first large language models came out. At beginning of last year, we had come to a point where LLMs had become a commodity in terms of chatbots you could talk to. They responded, and it was essentially a conversation that ensued between the users and the chatbots. That was it. Next slide, please. What has happened since is that these LLMs got smarter in decomposing problems, in actually breaking down strategies to approach and solve problems. They got better at reasoning, at planning, and managed to solve problems in in other ways that any AI before had been tried to do so in a very human-like manner. Next slide. The next slide, please. That has brought us to a point where LLMs have learned how to use other tools to solve problems. That's really the breakthrough step that we are at right now in the evolution of generative AI. These AI models have learned how to enlist the help of other tools, data. This could be non-AI or other AI models. These could be actual physical tools and robots. So it's not the large model itself that in its bowels comes to the solution and the answer to the prompt, but it actually breaks down what needs to be done into individual steps and then goes about selecting what's available in terms of tools and methodologies to solve these steps one at a time, and do this in a transparent way and feed the result back to the users and the researchers. That's really new. That's really exciting. That opens a whole new area of possibilities for scientists to engage with these assistants in selected spots of their scientific workflows. This is what AI agents do, and this is what we will be talking to you about and what we'll discuss and showcase in this session later down the road. A little bit of an outlook into the future. Next slide, please. What will happen next, if I may take a look into the crystal ball, is really on the back of this. We'll use these agents to create new information, new knowledge, and to actually dive into areas that haven't been scoped out before. So this is what I call the innovator age. And at the very top stage of this development, I foresee, next slide please, that this happens on an organizational level scale, not just on individual people, individual person scale, but on a whole organization scale. So there's an element of swarm intelligence in this, which we'll already explore as we look into agents. We'll hear about agent networks later down the road, agent architectures, how we can orchestrate agents to work together. And all of this, of course, at the hands and under the supervision of human researchers. Next slide, please. I'll not go into every detail of what's on this slide, but I'll point out a few important parts. This is essentially the business cards of what AI agents are. I alluded to a few of those elements just earlier when I talked about the evolution stages of AI and how we got to AI agents. The key takeaway messages here are that agents are large language models. They aren't your turbocharged huge large language models like the top end largest models. Often they're often smaller models that work with these large models, but they are generative AI modules. They contain what I call the user interface, right? So what you've seen about chatbots on the outset, you'll also see that in agents. There is a way to communicate with them, and it looks very much like chatbots. Just what's happened underneath the engine hood is what's new. They have a memory mechanism. You can actually start to coach and teach them to make them your personal assistants that know all about your field, your ways of working, and keep up to date on what happens there. They have a knowledge base. You can actually expose them to knowledge that you have, that your organization has, that your group has, and train them on that knowledge so that they become your really knowledgeable assistant. They can plan and reason. That's probably one of the most important features of agents. What I just said before, I want to just reiterate this because this is really the takeaway message here. We have models that connect to other models, connect to other tools, and know how to use them, know how to access them, and do that for you. These tool integrations are really an exciting element to scale what these agents can do. You'll see some of these examples later down the road. It can be tools that you build, tools that others have built and made accessible. It's really the glue that brings it all together. And finally, really reiterating that we can build agent frameworks, right? This is a network of helpers that we can structure, architect, and deploy in a way that helps your scientific workflow, what you want to do, the problem that you're tackling, and gets good at it. Next slide, please. Now, super important, right? I talked a lot about how these agents, how these assistants can be used to do scientific. One thing that I want to make utterly clear is that the scientific method does not change, right? You will hear people talk about the role of scientists changes and the way you do science changes. That's all true, but I want to be really clear about what that means. It does not mean that we deviate from the scientific method. Right? That the scientific method is one of humanity's greatest accomplishments. You're not going to deviate from it. It's just that we have tools now to scale what the scientific method can achieve. Some scientific problems are extremely complex. They actually go beyond what we can grasp as human researchers. The data that's involved, the multimodality, the complexity of the research questions that interact with each other. This is a construct that we can actually start to decipher and start to scale if we give AI agents into the hands of scientists. Scientists will still follow the scientific method. They observe nature, they form a hypothesis, they design experiments, they run these experiments, and then they analyze the outputs and test whether the hypothesis was true or whether it needs to be changed. That doesn't change. That structure and process holds up. But we can actually use AI agents to accelerate our path to solutions that would otherwise have been decades away or entirely out of reach. That has partly already happened. There's more of this happening further down the road. This will turbocharge the scientific method, and we believe actually give scientists superpowers. Now, with that, I'll leave you into the capable hands of my colleagues and our partners from Google, who will all walk you through some aspects of what I just said, show you how it all looks when it's actually applied. And I'm really looking forward to hearing your thoughts on this and engaging in a fruitful discussion throughout this session, and then even possibly afterwards, because this is a community effort, right? This is getting as good as it gets when we're all in it and we all, trust this work together. This is how we can uplift science through the use of AI. And I'm really looking forward to embarking on the journey with you. Thank you very much.
Thank you, Stephen. Hello, everyone. My name is Qing Hua. I'm a researcher from CSIRO Data 61. My research background is software architecture, so I will talk about how to build AI safety from the software architecture perspective. So first, let's look at the unique challenges of large language model agents. We put here the first one is complex architecture. So agents, as you know, is not just about large language models. It also includes other components like guardrails, external tools, etc. So we always emphasize we need to view the agents as a compound AI system and look at the entire AI system, AI agents, and address the challenges. Then the next one we put here is autonomy. So we know the input of agents, they are not very detailed requirements. They are just very high level human goals, and oftentimes they are underspecified. So the agents, they can make decisions or behave autonomously at runtime. For example, they can decide which tools they want to call at runtime or which data they want to retrieve to complete the query answers. And the behavioral agents, we say they are non-deterministic. So that means even for the same input, you can still get the very different results. So that's also brings some challenges about the reliability or robustness of the agents. And agents, we always expect them to be continuous evolving. So that means they can like continuous learning at runtime based on the human feedback or AI feedback. Then they can store the feedback in the memory to support the future interaction with the humans. So those are very unique challenges of agents. And we want to address those challenges from a software architecture perspective. And that's why the first step for our research was to define a template for designing agents. So we call them reference architecture. And in this diagram, you can see there are two types of agent roles. So one is coordinator agent, one is worker agent. So once the humans, they send the goals to the agents, the coordinator agent, they do the reasoning or do the planning, then they define the workflows, select the relevant worker agent to complete some specific tasks. Then the worker agent, they can use or select some external tools to help them complete the tasks they are responsible for. So that are the two types of agents for in the ecosystem architecture. Then this diagram is a more detailed design. Sorry about this slide. So you can see at the top, there's a layer called interaction engineering layer. So we have a context engine within this layer. Usually the agents in our design, we say they can wait for humans' instructions. So the human can send the goals through the prompt. But here we also think context can be very helpful for agents to guess the humans' interest. So they can make more proactive suggestions to humans based on the context they have detected at runtime. For example, the past interactions between humans and some platforms, or the document annotations, some highlights in the document, or the previous browsing histories. So they can be all viewed as context information. And the agents, they can make suggestions based on those information. Then once the goal is approved by humans, the agent, they can do the reasoning planning and execute the workflow. And during this process, the human evaluators or AI evaluators, they can provide feedback to the plans generated or to the workflow execution results, including the intermediate results. And as we said, they can be stored in the memory to support the future interaction. And on the right side, we put some responsible AI plugins. So they are, we call them guardrails these days, and they can be actually applied at different layers of in this architecture. We can discuss this later. And you may have noticed on the last slide, some of the boxes in the architecture, they are with gray background color. So they mean the design patterns for building agents. So we have collected around, I think, 20 design patterns for building the agents. And in software engineering, I think if you are from this community, you might be very familiar with this concept. So it's a reusable solution to a recurrent problem in a given context. And in our pattern catalog for the agent design, we also have using this template to describe the solution. So for example, we start from a very short summary, then we explain the context, the problem, and the solution details. We also analyze like the benefits and the drawbacks of the solution. At the end of each pattern, we identify like what kind of agents they have already adopted this design solution. So we call them known uses. And because these days many organizations they are developing agents. So we have proposed an architecture evaluation method. Maybe you have heard ATAM, but agents, as we said, they have very unique characteristics. So it needs a new approach for assessing the architecture at early stage. So this process starts from like understanding the human goals, then understanding the existing governance requirements. For example, in Australia, we have AI safety standard, and there are like 10 protocols or guardrails for the industry to consider to apply in the agent design. So we can identify the quality requirements or guardrail requirements based on those information. And in the meantime, we need to extract the architecture approaches. For example, what kind of patterns or tactics have been applied in the architecture. Then we can decide or identify the concrete context scenarios or prioritize these context scenarios and map those scenarios to the architecture solutions. So you can see the context scenarios are quite important to understand what are the requirements for the agents. So that's the motivation for us to define a catalog of agent-specific general scenarios. Basically, in the current version, we have one general scenario for one specific quality attribute. And we still use the old template. So, for example, for stimulus source, so it can be agent or can be users of the agent, can be the agent architect. And the stimulus could be a goal achieving request or security problem detected. Then you have the artifacts in the middle, could be agent as a whole, could be some specific artifact like memory or context engine to respond to this stimulus. And we also provided some responses, available responses. So they are actually available solutions to address the problem. And at the end, on the right side, you see the response measure. So how to measure your response quality. So the developers and the architect, they can consider using these general scenarios to define their own context scenarios for their agents to evaluate the architecture. And we also look into the evaluation process model, try to understand what should be happening in the testing process. And we still start from the understanding agent overall goals or the persona, the governance requirements, initial design. We need to develop the evaluation plan. And we have seen many benchmarks or model evaluation framework these days, but I think for agents, we do need to get domain-specific experts to get involved in this process so they can help us identify available open databases, or they can help us generate some initial testing data. So then we can, for example, use large language model to generate more testing data. And when we do the testing, we need to also get the domain experts involved to check the results. So I think these days we have seen many metrics, but those metrics are sometimes very confusing. We don't really understand the meaning of those metrics. So domain experts' feedback is quite important. So in the evaluation process, they can just, for example, one best practice is they just provide binary evaluation. So whether the response answer the query or not. Then they can also provide very meaningful explanation to this result. So these explanations, they can be very useful for the future model retraining, model fine-tuning, and they can be used to improve the agent design. For example, in the prompt, you can use this domain experts explanation in the prompt as negative examples or positive examples. So this diagram just like very simplified version of the agent architecture. We just want to highlight the role of evaluation. So we put it in the middle. So you see the evaluation results, they can be sent to the agent layer. They can be also sent to the model supply chain layer for the retraining purpose. And at the bottom, you see the agent ops infrastructure to support the continuous monitoring, continuous logging. And we also have the test safety cases here. So for auditing purpose, you may need to justify what kind of guardrails you have applied. And you also need to provide the evaluation results, like to show the effectiveness of your guardrails. So they could be very useful information, like as evidence in your safety cases. So it can be generated at runtime as well. And talking about guardrails, we first look at like how to characterize the large language model agent guardrails. So the first group, you see there are like some quality attributes we think they are very important when designing guardrails. For example, we design the guardrails for ensuring security, ensuring safety or fairness. They are like the external quality attributes, but sometimes the internal quality attributes are also very important. For example, we need to customize the guardrails, or we need to interpret or track the guardrails. So we see the interpretability or portability and also customizability. They are also very important quality attributes when you design the guardrails. Then for the design options of the guardrails, we analyze from different perspectives. The first group is actions. So what kind of guardrail actions available? Like a very simple example is you can block the prompt. The block can be viewed as an action, or filter some PII information, or validate a user goal. So they could be all action for the guardrails. Then the next group is guardrail targets. So here we classify the targets into two groups. One is, I think you have seen in many work talking about prompts or final results, intermediate results. So they can be considered as pipeline targets. And another angle could be artifacts. So they can be the artifacts can be generated at runtime, like the plans or the memory retrieved or the data retrieved. So they can be all as artifacts. Then the external tools the agent want to call can be also viewed as artifacts. So we need guardrails to check, for example, vulnerabilities of the tools. So we can decide whether this tool is secure or not for the agent to call. So artifacts in view could be very important when designing guardrail. And in terms of the rules, we need to design the rules based on the context, and sometimes we can also enable priority. So some rules may have like higher priority than the others, and some rules we call them soft rules. So that means they can be negotiable. And for modality, we talk about single model or multi-model guardrails. So guardrails can be for protecting text, but if like UI in the future is generated on demand, there could be some dark patterns on the UI. So you also need multi-model guardrails in place. And for source, I think here we try to see like the guardrail source. They can be from like industry level regulations, AI safety standard. They can be from your organization's own policies. They could be from your team level governance documents, and it could be your personal preference. So that's the basic taxonomy. And based on this, we have designed a Swiss cheese model for AI safety. So here we try to design a multi-layered guardrails for the agents. So still the left side of this diagram, you see the basic workflow of the agent. So it includes context engine, includes reasoning planning, and workflow execution, and they can interact with the external environment. And on the right side is a multi-layered runtime guardrails. So we have like different layers of cheese within that Swiss cheese model. And we currently the design covers just 4 dimensions, including taxonomy. I think taxonomy aspects like the quality attributes, the pipeline or targets, or the modalities, and can be also actually actions. So we put some examples in the middle. For example, the first layer of the cheese is the privacy guardrail for the multimodal prompt. Or the next one could be the safety guardrail for the goals from the humans. And then there could be security guardrails for the external tools, can be fairness guardrails for the final results. So they are just some examples. You can have like multi dimensions in your guardrails. And here I think the main point is each layer, they might have some weakness, and it's actually the holes on each layer of cheese. But by having a combination of the layers, you can have like a more robust defense against the risk. So even the risk, they go through one level, they can still be protected at another level. So that's the idea of this approach. And still the end, we put agent ops infrastructure. And here, just want to briefly talk about the agent ops template. So we have seen large language model ops or DevOps ML ops very often. And here, we just try to understand what kind of artifacts or data that should be recorded, monitored at runtime. So the left side is just a relationship diagram. You see the relationships between different artifacts, like for example, agent and reasoning, they can have like 0 to n relationship, or agent with plan, they can have 1 to n relationship. So on the right side, we try to understand the tree. For each trees, we can like monitor the agent span. And for agent span, there could be reasoning span, the planning span, the workflow span, guardrail span, evaluation span. Then you need to rely on large language model to do that, or external tools to do that. So we also include large language model span and the tool span. And I think the bottom part is just like metadata for different kind of span. So you have some like basic I think understanding about the template, what should be recorded by the agent ops infrastructure. And the last slide I have here is actually some screenshot of our current agent platform version. So I think the users, they can, it's like a no-code, low-code platform. So users can use natural language to communicate their requirements. Then the platform, they can interpret the requirements and put it into a very structured form, including the agent persona, the scope of the agent, the guardrails that are available for this agent. They can also visualize the workflow, and the users, they can adjust the order of the workflow. But that's mainly for the design time. At this stage, we are implementing the framework I mentioned just now. So we are implementing the agent ops infrastructure, the guardrails, the runtime evaluators. So we want to have like a more comprehensive version, including the runtime considerations. That's all about my part. I will hand over to my colleague, Samnas, to continue to talk.
Thanks, Xinhua. So I'm Samnas. My background is natural language processing, and I'm going to take you through one of the tasks that we're tackling in AI for science program, and that's summarization of scientific literature. So if Xinhua hasn't convinced you that evaluation is important, I have this one slide there to emphasize that evaluation nowadays in creating an AI system is really has to be part of the life cycle of developing the system. And in fact, according to some of the tech companies, the value of it is getting higher and higher. And currently, it is estimated that it will be at least 20% of the job that somebody has to do for creating the systems, which can translate to a good $92 billion value just on that evaluation aspect of it. And this is not going to be a simple task. In the past, it was usually a static thing that we would do. That to evaluate, we had this framework with data sets, evaluate your component, and that's done. But it's no longer valid with large language models and generative models, that they have non-deterministic output, and therefore you don't get the same output each time you run it. So you have to think about how to evaluate it now. And there are many different criteria to consider now that can be different to what we had in the past. It's not just precision and recall. There are other aspects that you need to consider, such as fairness and transparency, and customized metrics for your task, for your users. So what I'm going to talk about is for this specific task of summarization that we're looking at within our program. Why we look at it? Well, we are hoping to develop tools for scientists, and one of the things that scientists deal with on a daily basis is reading scientific articles. For example, in PubMed, which publishes biomedical articles, we currently have over 37 million papers published, and something around 1 million new articles gets published every year. it's impossible for any scientist to stay on top of this. And on top of it, sometimes you need to learn about science of somebody else. Like I'm in NLP, if I want to learn what Xinhua is doing in software engineering, or if I want to learn about someone's articles in medical area, I won't be able to understand the summary if it is in a very technical term. So we might need summarization that is tailored to non-experts. And I'm going to call this a plain language summarization. Summarization comes in different forms, as it can have different types of input. So you might have text that comes in the form of scientific articles. It can be reports. It can be graphs or figures, or it can be tables of results. And it's important to know that sometimes scientists are interested to know the summary of one single article. So we call it single document summarization, or they might want a summary of multiple documents together. So that's multi-document summarization. And that need comes based on the context that they use, what they're after. And that also, again, we have to consider the context and the users. Who is going to use your summary? Is it a scientist that is specialized in the article, or is it somebody else? And that would define what type of summary you have to generate. And for the sake of our program, we are basically looking at summarizations that are suitable for scientists. It can be single or multi-document summarization. It is abstractive, not extractive. And you probably know what's the difference, but the abstractive summarization is what is generated, like we would write as a person for our papers, for example, whereas extractive summarization, that is something that has been studied for a long time in the NLP community, and that's when you extract pieces of text and put them together as a summary. So that was something that was mostly worked on in the past, but with the generative models coming on, we're able to do abstractive summarization. Sometimes the summary, and we are after summaries that sometimes are question focused. So scientists might have a question and they want the summary of an article to be tailored to that question. So it's not exactly the answer, but it answers their question. And we always need a domain-specific summary. So that's what we are hoping to achieve. And obviously, if we said we want abstractive summarization, and LLMs are there to do generation, so they do they have to generate good summaries. But is it true? So this is the question that we get asked: are these summaries that LLMs generate, are they reliable? Can we trust them? So that's the research that we've been doing in the past 1 year in particular. But before I get to what we've done, I'd like to mention a bit of a history of what in the NLP community has been studying for decades in the summarization domain. So there has been lots of metrics out there, and there is still used, such as Rouge, Blue, and they've been proposed quite a long time ago, and they're still in use for evaluating summaries. And what they do is they are n-gram based, so they have the pieces of text has to match. They often rely on the human reference, so you have to have a summary as a reference that is created by a human, and you go and say, okay, this is we created this summary, does it match with what the reference we have? But if it is n-gram based, somehow we're missing the semantic matching that should happen, because as a person, we don't always write the same way. You might write in two different ways, and they mean the same thing. In more recent research in the NLP community, they've been looking at uses of summary and the methods of summarization, and how that would affect the summarization evaluation as well. So such as question-focused summarization. But how suitable are those methods that are so established in the field for today's needs? And that's basically what we call meta evaluation. So evaluate the evaluators. Are they good now? Or can we rely on those evaluations? Can we still rely on Rouge to evaluate our summaries? And to answer this, we've been looking at, we did a literature review of looking at every possible summarization papers that was published in the past, and to see whether what sort of metrics are there, what sort of data sets they're using, are they suitable for our program, are they suitable for our scientists, for the tools that we are developing. And what we found is that most of these metrics and most of these data sets that are out there are very generic. So mostly on the news data sets. So they're not really suitable, most of them, for our purposes. And in the recent past, some of the literature points out that a lot of these large language models generate text that is very readable, is high quality, but sometimes they may or may not stay true to the content. Obviously, you might have heard of hallucinations. So what we recommend is that to consider several dimensions when we do the evaluations. And I'm going to explain a few of the dimensions that we identified: faithfulness, factuality, finding the evidence, and readability. So faithfulness, for faithfulness, we've been looking at how faithful are the generative summaries across different LLMs. Do they stay true to the original content or not? And with that comes factuality as well, which I will explain in a bit. And then we find a correlation between faithfulness and readability. Would for example, being more readable make it less factual or not? For supporting evidence or finding evidence, we also ask these questions: are if LLMs can identify supporting sentences, for example, from the original text or not, and if we instruct them to do so. So if they generated a summary, can they go and find the evidence that supports the summary they generated or not? And how much interaction exists between abstractiveness and the identification of those supporting sentences. This is an example of what we've basically testing on. So we've got a scientific article on the left, and generated summaries from some LLMs. And through this process, we saw very interesting patterns. We saw like different LLMs have their own style. Some of them would be very distinct, like, they would start by saying that this researchers in the organization blog this, and they always created the same type of summary. So you could, after a while, you can identify almost which LLM generates which summary. So the setup that we had here is like this. So it is just for our research. So we picked some PubMed articles from the recent articles that after 2010. We picked some random articles. We pass it on to 7 different LLMs, and then instruct them to generate plain language summaries. So it has to be understandable for somebody who is not in the field. And then we asked 2 domain experts in the medical domain, 1 surgeon and 1 clinician, to tell us whether or not the generated summary is faithful per sentence and on the summary level or not, and can they find the supporting evidence in the original text. The reason even though these are plain language summaries, still we needed the experts because they have to understand that original text to be able to identify the evidence. So that led us to create this data set. It's public, you can use it. It's called Fair Bio, Faithful faithfulness and reasoning in biomedical data set, which is fully annotated and it has all the evidence and summaries corresponding to the articles. And when we analyze the data set that we identified, we realized that almost all those LLMs make some sort of mistake. So there's at least 8% of the summaries had some level of hallucinations. Some of the LLMs were up to 72%. But there were two types that we could identify. Some of them were factual. So it is a sentence that it is correct, but it just isn't in the original text. So that's what we call factual hallucinations. And then some of them were plain wrong. So not in the text and it's incorrect. So further analysis, we realized that the reason some of those factual hallucinations are happening is because we're instructing the LLM to create plain language summary, and they go and bring you some background knowledge that might be useful in the summary. So depending on the application, this can be good or bad. And then we also identified that the more abstractive the LLM was, so the more the more they didn't use the original text, they become more hallucinated. So there was a direct effect between abstractiveness and the problems that they generated. Then the next set of analysis was about finding supporting evidence. So can they identify, if you instruct the LLMs to go and tell us where did you bring this information that you've put in the summary, can they identify them or not? So the baseline here is something, it's a very simple statistical ranking model, BM25. So we provide a summary to BM25 and ask them to, we get it to rank all the sentences and we take the top one as the supporting sentence. So it's very simple. And we do have the judgments in our data set, obviously. So that the best we got is 1.63 F1 score, which is, isn't that high, but it's okay. But LLMs were much worse in that sense, even though they were generating the evidence, but none of them could really reach to that level of even a simple statistical methods. So I guess the lesson here is that if you want to find the supporting evidence, we don't really need to spend the resources on using LLM for now, but I'm hoping that this will improve. So the next question here is that, okay, we created this data set. We used experts to annotate them, but this is a small data set for biomedical text. What about other domains? It's very difficult to create such expert annotated data sets. Can we use LLMs instead of those human evaluators or not? Is there a way to get around it? So we did a few more analysis on that data set to know how much correlations exist between what humans judgments were and the LLMs that we were testing on. So for faithfulness, we tested them, we compared them with some of the well-known metrics in faithfulness that has been published in the question answering community. We tried to see how much correlation exists between those metrics and the LLMs. And there is, I guess, what LLMs could identify some of those non-faithful sentences, but not all of them. So the recall wasn't that high. The other question was, do LLM consider their own generations more faithful than the other LLMs in zero-shot evaluations? So if you prompt LLMs to rate their own and other LLMs generation, what do they prefer their own or not? And that's important because that would kind of would reveal to you whether there is a bias there or not. And we did not find any bias, even though, at least for this setting. So in the generic domain, some people have identified some bias, but in our data set, we could not see any strong evidence in that. The next study that we did, this is on a different data set, not our own, but is again to answer whether or not LLMs can be used for question-focused summary, to evaluate question-focused summaries. And for this one, we used a data set called BioAsk, which is human, it comes with human judgments. And we tested 5 different models for that. And basically, we did the correlation between what we instructed the LLMs to measure the quality of the generated summaries against 4 different criteria: precision, recall, readability, and repetition. And we have the same judgments from multiple experts in that data set. And we basically, there's a lot of experiments in that paper, but the gist of it is that there was still room for improvement. So if you cannot still replace any of those human experts with any of these LLMs. But once we did fine-tune LLMs, specifically GPT 3.5 and 4, they were getting close, but not yet to that level, basically. So did I answer how good is the summary? I guess it depends on who or what. So in what context you're using the summarization, for what field. It really required multiple dimensions to consider when you do evaluation for this task. And as new models, so that all our experiments are, even though recently published, is around 5 months old, I bet everything has changed in those models. So we need to reassess, but at least the dimensions and the framework can be the same. So that's all I have. All the papers and that we discussed, Xinhua myself, are in this QR code. Thank you.
Let's share.
Good. We're just gonna play with the. Yeah, awesome. Worked first time.
Cool. Okay, because I have some demo to show, so I switch over to my my laptop. Yeah, thank you very much for Stefan, Qinghua, and Simon's great insights. So my name is Jasper Wang. I'm a lead customer engineer for research. I'm also GenAI specialist in Google. If you look at the event website, you'll probably notice I'm the only speaker who do not have doctor in front of my name. So I'm really humbled. So I hope one day one of them can take me as a PhD candidate. Okay, so in my part, based on what Stefan, Qinghua, and Simon shared, really those great insights, I just show how Google approach those great ideas and to make it to be manageable service for you to utilize. Hopefully it can be utilized by you straight away for your own scientific discovery. So a little bit of background, just set up the stage. Google is actually quite a big company where we have a lot of things going on. Even ourselves in Google can be lost. So, but anyway, but from scientific perspective, Google is actually uniquely positioned to impact science for good. We actually help science, contribute to science community from many angles, including Cargo Colab. Probably most of you might be already using Colab for the last few years. Also, we have Google Earth Engine. It's already a lot of people love it. So then, but today I will particularly focusing on Google Cloud, where how the GenAI service from Google Cloud can help scientists. And also the other fascinating technology and fundamental innovation from Google DeepMind. Okay, so from Google for Science perspective, we're particularly laser focusing on three aspects. One is that we're trying to using AI to accelerating science. So this is particularly reflected in DeepMind work. For example, the AlphaFold, which changed the structural biology for forever. So then, for example, AlphaFold 3, I think 2 weeks ago, the source just actually open sourced. You probably can try it by yourself on your own server, or maybe on Google Cloud, even better. So that also you probably heard recently, I think just last week, DeepMind released AlphaFold Qubit, where it's a fundamental way to revolutionize how you correct the quantum computer errors. So that is the first time actually make a quantum computer to be practical for many use cases. So another for which quite align with what we're talking about is that we're also focusing on large language model and also science focused agent. Later I will show you some kind of really cool tools you can start using now. Hopefully it can make your life a bit easier. Then also as a Google Cloud, I'm in Google Cloud team, we actually provide a solid platform for research. So today I'm just focusing on those two aspects about the large language model and the science agents. So just a little bit overview architecture about how Google organized GenAI service and make it available for enterprise customer and also scientists. So the Vertex AI is our unified AI platform for research and also for you to build GenAI agents. This is built on top of Google AI optimized infrastructure because we have been running 9 billion user apps now. Every apps have all the AI superpowered. So we know how to scale and operate AI at a large scale, very cost effectively. So that benefits actually transfer to Google Cloud customers as well. Then within Vertex AI is the name, the brand of our AI platform. Within Vertex AI, it has multiple levels. First, at the lower level, we have the Vertex AI Model Garden, which is the core service there. So from there, you can access in a fully managed way by Google. You can access Google first-party model, including Gemini 1.5, which we're going to touch on later. Also, the very popular open source model like Llama 3.2, Llama 3.1, and also partner models like Anthropic, Cloudy 3.5, particularly good for coding. You can all access that securely from Model Garden without managing any infrastructure. Then on top of that, as someone has actually touched on, the fine-tuning and argumenting the model also important to make it practical and also easy to use. We provide this level called Model Builder, where you can argumenting the out-of-box by prompt management and also long context prompting, as well as the fine-tuning all those kind of technologies and tools for you to make the model behave and also specifically for your own specific scientific case. Then we go to the top end where we have the layer called Agent Builder. It's providing all the tools, which I think Xinhua touched on, where if you're building a whole agent, all the tools you need, and also all the, not just large model itself, including the surrounding large language agent evaluation, agent operation, all those tools has to be part of the whole ecosystem. Then you can have a practical GenAI agent. That's where the Agent Builder is actually helping. So then, on top of that, Google brought from Google Cloud, also from other Google Labs team, we actually built the GenAI agent as a service. You can start just straight away using it. You don't need to have any scale on AI itself. Also, on the same platform, you can actually build your own generative AI powered agent. Just at this moment, we're actually working with very awesome scientists from CSIRO to focusing on using the Vertex AI to build some scientific agent to help their research. This is the platform. So now I particularly zoom in about the agent. I think Xinhua gave a very detailed article really well about what agent looks like. But for now, I just want to make it drastically simplify it. So basically, it has a reasoning loop, it has a model, it has tools. Also, for multiple agent, it also need to have communication channels. So based on those kind of very simple model, I just want to zoom in for each of the component to show what Google Gemini services can simplify the implementation and the building of those kind of components. So first, let's start with model. So the latest model version of is for us is Gemini 1.5. Gemini, I think it's a Greek word. It's talking about two things, twins. Its twins also relate to some star trips. Anyway, the main naming behind it is because that's the first groundbreaking product come out of the merge of two the best AI organization on this planet, Google Brain combined with Google DeepMind. That's kind of this their first joint product. So that's kind of because of that they name it Gemini. So then Gemini 1.5 is the second iteration of this particular model. It has two flavors. One is Gemini 1.5 Flash, which is very fast, also very cost effective. It's natively support multimodal, has very low latency, and also 1 million context window. I will explain what does that mean in reality. So it's actually from a quality perspective, it's close to the next I'm going to show you, which is Pro. So this is a bigger model. It's more capable. Also, it's natively support multimodality. And it also support 2 million context window. What does a 2 million context window mean? It means a lot. So it means it's more than 1.5 million words. The whole series of Harry Potter is 1.1 million words. So in other words, you can put all the Harry Potter in one context, then ask questions in one prompt. So someone using that to generate the character relationship graph of all the characters from Harry Potter, which is quite amazing. So on the other hand, we do realize the larger context window, if every time you have to send such a big context window plus your questions, every time from scratch, it will be A, quite costly, B is that it could be also, the latency will be much bigger. So that's why we have a paired with a very cool feature, which is unique. It's called context caching, where this is particularly useful for scientific research. Because in many cases, we saw the scientists have a bunch of papers as the basic context, then they tend to ask all kinds of questions, follow-up questions. So in this particular case, you can cache all the scientific paper, 20, 30, 50, whatever, as long as it didn't include exceeding the 2 million context window limit, then you put it into a cache. Then you can start asking all kinds of questions. The result is that if you don't do that, obviously every token you have to pay for that, including all the bunch of papers. But with context cache, the first benefit is that first of all, the input token has been significantly reduced because every time you just send the question itself, on the other hand, the big context of all the papers are actually already cached. By this way, the cost is at least 75% reduced. The other benefit is that the latency also significantly increased in that particular scenario. So we have been tested with a few scientific paper use cases. It's performing really, really well. So also just want to circle back to what I think in Qinhua's part, she also mentioned the prompt management is also, and generally prompt optimization is also important for for the agent to behave better. So that's why we have the prompt management service, where provide prompt watching history and the governance, as well as the importantly, it's actually give you a suggestion about how you would like to prompt the large language model in a better way. So we also have an inline help there. So I don't know whether I have time to demo, but we can show you in the console fairly easily. So the other important thing is that we also provide the prompt evaluation, where you can do side-by-side comparison, then give you a better prompt for you to do the research in a better way. The other major part, I think Simon has touched a lot on this, is about GenAI evaluation. It's very much aligned with what Google Cloud Services provide here. We provide a very comprehensive GenAI evaluation tools, where cover both the mathematic metrics, which Simon has touched on, like large, and also BERT. What's the BERT something? I forgot what's the other one. But also, we touch on we also provide a built-in service for another large language model to evaluate the target large language model's response, including you can define all kinds of metrics, including groundedness, means that how grounded the response is based on the content. It's very much aligned with what Simon was talking about. So now we talk about model and also all the things supporting the model. I only pick up the key ones. There's a lot. If you allow me, I can go on for the rest of the day. So, but next, let's move on to the tools. From tools perspective, tools are important in agent, where it's actually enable the large language model to actually interact with external systems to actually make a difference. So in Google, we provide two types of tools in general. We have a lot of tools, but in general, it's two types of tools integrate with external APIs, including extensions and also functional calling. So I will explain what's the difference. But in general, extension is have a fully autonomy for all the way from invoking to execution. But function calling require a further guardrail and kind of intervention in between for you before you call the API. So basically, it means if you have a very not so secret API, you can straight away using extension. Basically means the Vertex AI will be responsible to making call to the API that straight away feedback the response to agent. So from your perspective, from user perspective, you just know you don't have to put any custom logic and control it. But if you have quite a secret API where you want to control how the API is called, then in that case, you're using function calling where the agent give the response about how you call the API. Then the UI or the middleware will make the logic about actually calling the API instead of delegate the execution directly to the Vertex AI. So the other major part, which is part of the agent, is the rack and also grounding. If you want to build a grounding process, a grounding system or a rack system, you have to do all those things by yourself, all the way from document collection, process annotation, embedding, index it, also then re-rank it, then generate the response. All those things. If you actually build one in operations, you probably can appreciate the complex and the efforts required to build and maintain this system. But with Vertex AI Search, we actually wrapped it up to be all fully managed service. In fact, it's basically giving you a GenAI powered Google search for your own contents. Some of the demo I'm showing actually have this technology underpinned those service. You can see how amazing it is. So in addition to that, we fully realize in some cases you really want to fully control your rack. So that's how we actually make each of the APIs to be standalone API, which are underpin the service itself. By using those standalone APIs, you will be able to build highly flexible and customizable rack by yourself, if that's what you prefer. But for most of the customer I'm currently working with, including CSIRO, we would suggest that Vertex AI Search to start with your rack system. So another beautiful stuff of Vertex AI search is that we think from an ecosystem perspective. We know enterprise, including research organization, have siloed information across all kinds of systems. So that's why we have hundreds of built-in connectors to deal with all kinds of knowledge base or systems that enterprise might have, including Jira, including Conference, including SharePoint, and also OneDrive, Google Drive, all those kind of information. Then all those connectors built in inside of Vertex AI Search, straight away we'll be able to index that very easily into Vertex AI Search. Then on top of that, we have the blended search. Then basically you have virtually means you have a Google search on top of all your siloed information across all the systems to provide you a Google quality search across all of them. Then also give you a meaningful response and a summary about those contents. And plus the citation. Then furthermore about grounding. So in addition to actually you build a Vertex AI search using what I just mentioned, we also support grounding with Google search, where when you ask a question to Gemini API 1.5, for example, you ask a question, the model will make a judgment whether I know this or not. If I don't, then I will go out to Google search to get the relevant information to respond to your question. So this is highly relevant and very useful for scientific use case. Also, in the second part, we have grounding on your data. That's what I mentioned. Well, once you build your Vertex AI search across all your data sources, you virtually have a Google search engine for your own data. So that's by that you can grounding the large language model response on that particular base. Then the other interesting thing is I'm actually only dreaming at the moment, but hopefully it become true, which is we have the grounding with third-party data where we know a lot of very popular data provider, for example, Moody's or Thomson Reuters. They are particularly important for financial research. So we have native integration with those kind of data provider where when you're making call to Gemini 1.5 API, it will automatically grounding on those third-party data provider. My dream is one day Google Scholar will be that kind of third-party data. But at the moment, it's just a dream. I don't know how much I can make it a reality. Hopefully, if I get all your signature, I petition and send to the product team. Anyway, that's a joke. So the other thing is the last one is grounding with high fidelity. This is a special flavor of the model where circle back to what Savnas actually mentioned. This model is a special flavor where it's fully grounding every single response about its the response is generated on something. So that's what we call high fidelity. But this way, this is particularly important for financial research where they need the information and the response to be fully precise. That's the thing we actually provide another flavor. Also for scientific research in particular, it's around some, I don't know, has to be high with high precision response. That's also another very good option. So we talked about the rack where you can using Google Vertex AI Search to build your own, or you're using the Vertex AI Xcode API to build your own as well. On the other hand, we're fully aware some people or scientists might already using some open source model to build their rack. That's why we have the rack engine service as part of Vertex AI. It's basically a Llama index on Vertex AI, where if you have a Llama index where you're familiar with, then also you already build a rack system. You can simply using a very simple SDK where it will be, you can say just by 5 lines or 10, then you get a fully optional Llama index rack system running on Vertex AI, fully managed by Google. So now we touched on model. we touched on the tools supporting model. Now we actually show you a real, even a higher level service where we call Vertex AI Agent, which is also known as playbooks. Using this kind of a tool, this is a no-code approach to build a production-ready agents. Where here, this is the console of this, how you build an agent. To start with, you give a goal, which is a high-level goal, what you want this agent to do. So it could be that help me to help me to research on cancer related research, and also generate the literature review, all those kind of goals you wanted to do. Then you using natural language to describe step-by-step instructions for what this what steps you want this agent to do, and also it's just like you teach a postdoctor to do the things you want the postdoctor to help you. So then you can just describe that. Then of course it won't be as smart as a postdoctor on the other hand. But anyway, so it's just kind of similar idea. So then after that, importantly, you can also link in the tools, then which will actually reach out to Google search, for example, then also search against the Vertex AI search data store you just built to get all the relevant information, then actually taking actions based on the instructions. With this, I think in about 20 minutes, you will have an agent running. Then you can further fine tune it to make it cater for your own purpose. We know that not everyone just using out-of-box tools. You may want to have a fully flexible way to build agent on some very popular framework like LangChain to start with. So here we have the reasoning engine, another service on Vertex AI platform. It's supporting quite a few open framework already. So including LangChain 1.2. 1.2 is another agent development tool coming from DeepMind. So basically, that is a fully managed and runtime platform where you just need to using a SDK and to deploy the reasoning agent on top of your LangChain code on top of Vertex AI. Then Vertex AI will be responsible to managing all the infrastructure, the API, the security, and also the ongoing operations. So at this moment, we already support this reasoning engine already support LangChain, LangGraph 1.2. There are more are coming, including hopefully next year we probably can get Clue AI. Early next year we probably can got Clue AI also supported here. So the other thing I want to quickly touch on is also help you to do the agent is the actual notebook or the entry point where you can play with all your code. We have a Colab Enterprise on Vertex AI. I think for the people on the call or people here in the room, most of you probably tried Colab one before. It has its own limitations. It's very popular, but it has its own limitation, including it doesn't have the enterprise-grade guardrails, data residency, all those kind of limitations. In particular, if you want to get a GPU, that's kind of a lottery. So depending on how lucky you are, you might get today, probably won't get tomorrow. So that's where the Colab Enterprise bringing the value to the people who is working on Google Cloud, where it have the same experience and the collaboration feature of Colab, but it provides. It's also you don't need to configure any configuration or infrastructure, but it's also allow you to do. You can secure a GPU very easily to dedicate it for your own Colab instance. It's get rid of the limitations for the normal Colab. So now I think those are all the tools from Vertex AI platform for you to build your agent. I now want to show you something which really cool is from Google Labs. it's ready to use Gemini agent to help scientists to build to start using it straight away. I'm going to touch on two of them. One of them is called Notebook LLM. I don't know how many of you already tried or heard about it. This is named as one of the best innovations by Times Magazine for 2024. You can now access it freely. It's respect all your data privacy, which means Google is not going to use it to train the model, and all the data is private to yourself. If you need the business, if you need enterprise grade guardrails, a business version is coming soon. For now, everyone can go to the individual version to start using it. So what it can do is you can say in my quick demo shortly, where you can say that you can talk to a set of documents and a research domain you're focusing on. Then also you can do a very cool podcast. I will show you what it looks like if you haven't seen it before. But also I will share some really exciting roadmap items just coming in next year. Then also, it's back to that Savnes touched on, where the citation is super important for scientific research. This is where the tool is very highly capable of generating inline citations for all its response. Yeah, you can also generate literature review, very comprehensive one. This is one of them. The other one I'm going to touch on is Data Science Agent, which is another tool coming from Google Labs team. This tool currently is only accessible from US, but hopefully very soon it will be accessible from Australia. What this tool does is you can generate a new project. This is trying to tackle the challenge where not every scientist is actually a data scientist. But in most of the cases, they have to deal with some scientific data to clean it, to generate meaningful reports. So this agent is targeting that exact use case where you can dump in all the relevant structured data you got from your instruments or from your observation or from your experiments. Then you just prompt it what you want the agent to do. Then what this agent is going to do is it will start planning how I can achieve the goals you ask me to do, give you a plan, then you accept the plan, then it will automatically generate the Colab's code, then run it, and all the way to the end, what you want to achieve. During this process, you can fine tuning and tweak it, but in general, it's significantly reduce the efforts and also the knowledge required from the scientists when it comes to data science perspective. I will show you a quick demo as well. Okay, now it's the demo time. Hopefully, I still have some time. I'll quickly show the notebook to start with. Here, this is the notebook URL and also the landing page. You can just refer to your own Google account to start using it. I actually right now started using it on a daily basis. So the thing is that for each of the things you want to do research, you can just upload it into the sources. Here you can say that you can upload it from your laptop as a PDF or from your Google Drive, or even just a URL. Maybe you can put in a URL to point into the scientific paper online. Regardless, then you can just add it in. Once you add it in, it index all of them. Then for each of them, it's generate a very cool summary. I would be very interested to using a soundness framework to validate how good the summary is. But you can say that it looks quite cool. It gives you all the summary about this particular paper, then also give you all the key topics about what this paper is about. So this is already quite helpful. Then in addition to that, you can then start ask questions. For example, even before you start, you can say it's already proposed some question you can start asking. But for me, I probably just want to, by the way, this credit to a CSIRO scientist. This actually exercises, he helped me to put all those papers together to make it meaningful. So this is about cancer research. So I just curious how what I can start the chat with it. What are the main themes across those papers? Sorry, typing in front of 100 people is a bit nervous. So then behind the scene, what happened is this tool, by the way, is supercharged by Gemini 1.5 Pro. Which minor version, I'm not sure, but it's Gemini 1.5 Pro. Because of the Pro high, very cool reasoning about the multimodal support, multimodality support, as well as high reasoning, important, particularly the big, context window, it's making it possible. So here you can say it straight away give me all the key themes here. Actually, not a cancer expert, but anyway, according to the CSIRO scientists, this finding is really cool. So this is spot on from cancer's research perspective. So then in that case, I just want to say, elaborate a bit more on the first thing. So then what it does is it can say not only give you an overview, it's also very good at digging into all the information in a scientific way, actually get the results, which is spot on and also very detailed. So in addition to that, for each of the citation, it actually give you exactly link back to the paper where this thing is based on. So just some kind of anecdotes behind it. There are two main people behind this particular service. One of them is called Stephen Johnson. He's actually he's the bestseller for 14 books, bestseller of New York Times. Google got him into the Google Labs team because Google's idea that technology is one thing, but if you want to make a research tool, you better get people who are actually doing writing and research. So that's why we have some. We also have working on some music tools. We also get some musicians into the team. That's the that's the funny part of how Google approach those problems. But this way, it's coming up with this content. Then also, in addition to that, you can generate a podcast. I just played. I already generated, but I just played.
Stack of research papers here, some super technical and others more of a general overview.
Yeah, the good mix.
Yeah, definitely. So we're going to break down BRCA1 and BRCA2 mutations, how they affect cancer risk, and what that means for treatment. It's like finding a chink in the armor of these cancers, right?
Okay, it's about 90 minutes. So in other use cases, very soon that's a very exciting feature will come in for this particular part where you will be able to define the personas. So some example is that you can define 2 or 3 personas. In particular for cross-disciplinary research, you want one to be the structural biologist. The other one will be agriculture expert. The third one could be that critic of science. Then you can ask those 3 people debate in this podcast. And even more, another feature coming is you can call in to that podcast, just like you are working with virtual 3 scientists together to actually brainstorm and as part of that podcast. I just can't wait for that to happen. Okay, this is a notebook. Hopefully that give you some kind of inspiring you to do something. The next demo is slightly a bit boring, which is the data science agent, but the task itself is really boring. I have data scientist friends here, but anyway. So here you can go to the playground. So what we do is that we worked with CSIRO, awesome CSIRO team where they are doing the blue carbon seagrass research. Then they are kind enough to share this data, which is a bunch of very hard to understand structured data. So if you look at this is look like this spreadsheet. So which you can say, unless you really understand it, you don't know what it's talking about. So then what this tool can do is, back to this tool, all I did is that I uploaded this CSV file. Then I put in a bunch of a long prompt, which I'm going to type in here. So the whole contents, you can say this part, is just description of each of the columns and the tables. Okay, so then after that, this is the actual question and what I want this to do. So all it does is that then you can start continue, just ask it to continue the task. Once you do that, what it does is that it gives you, hopefully it's coming up soon. Behind the scene again, it's powered by Gemini. So what it does, it gives you a plan. So start with data loading, data preparation, data wrangling, data visualization, and finish task. So if you're happy with that, you just continue, or you can refresh it. But in my case, I will just, I'm happy with that. I continue with create a collab. So what will happen is that it's will actually create a collab notebook and actually run it and actually validate its correctness and whether it have an error. So then here, just give it a minute. So here you can see that it start with the, summarize the planning first, then start in real time, generate the code for data loading. I hope it works, by the way. So then it's actually trying to actually load it. You can see that. Then also it start doing data preparation. Okay, we'll probably come back probably after a couple of minutes. I will just finish my slides. I think my time is running up. So I'll show you the results at the end, I promise. So then we also have a very comprehensive example. I don't expect you to remember the architecture diagram, but it just show you a fully customized GenAI agent built on the service we just described. For this one, you have we have the open source solution. You can see it have multiple agents developed on Vertex AI that you can do. Building this, you can talk into your scientific data in natural language. So in summary, today I just touch on based on what Stefan and Qinhua's Soundness elaborated. We'll just touch on my part. I just touch on the Vertex AI as a platform itself, and touching on a bit on the Gen AI services within how to help you to build Gen AI agent, and also give you some demo about Google provide ready-to-use Gen AI agent. And lastly, show you a quick example of that. Hopefully that's all meaningful to you. So then this is the go-to GitHub repo where we have all those customized agents available. The code available for you to adopt and to start with. So it's a good reference there. Lastly, let me coming back to the. Okay, you can see here. So the data loading is done and the data preparation is done for my purpose. Then also it's done the data wrangling. All those code are generated by Gemini. So also it's actually doing the data visualization. So it's coming up with this kind of, it's coming up with the results showing here. So hopefully it's making sense. So then in the end, it's give you a summary about what has been done. So that you can download this Colab, open it in Colab or Colab Enterprise, or download the notebook. So it's hopefully by this way, you don't need to be a data scientist to do scientific research. Hopefully, all making sense. Sorry, Scott.
No, keep going. I'm just checking the microphone.
I think there's some Q&A time. Is it?
Yeah, hopefully we got some time for questions. So I'm just gonna. Yeah. Let me go to.
Stop presenting.
That's okay.
Stop presenting.
Yeah, do you want to stop presenting for a sec? Okay, just for those of you online, if you haven't already, jump into that. You'll see in the bottom right of your screen, there's a I don't know what you call it, a little multi-shape button. If you click on that, you'll see a Q&A tab, and that will allow you to jump into the Q&A feature, which I'm going to open up now. So for those of you online, take the opportunity to vote for your favorite questions. But while I'm setting that up, are there any questions in the room? Or let's just start with the room at ANU to give you guys a chance. Pablo, I don't know if you want to come off mute and let us know if there's any questions in your room.
Yeah, we have a question here, yes. So
Great.
I've just gone to the data science agent and tried to click on playground, and I'm getting access denied. The feature is not available in your region.
So right now it's only for US region. It is coming to Australia soon, hopefully.
Okay, thank you.
And the VPN will solve it, right? Yes.
Any other questions at ANU?
When is the context caching coming out?
So the question is, when is the context caching coming out?
It's already GA. GA means general available. It's already available on Google Cloud.
All right, thank you. And I think that's all. Thank you.
Awesome, thanks. I'm hoping Stefan is going to join. I know he's been having some computer problems. Let's go to, okay, so we've got voted questions here. Actually, before I do that, is there any questions in the room here? Before we get started.
Is it only for the last lecture?
No, I'm hoping Stefan will join, but we've got our other two presenters in the room, and hopefully Stefan will dial back in a second as well. So questions all the way back from the beginning.
For the first lecture, I wondered what is the rationality models on the reasoning parts that use the LLM as models, but what is the framework for ensuring rationality on the reasoning engine itself, or the reasoning is just a stub that could be driven by rules or human dictated logics?
Yeah, we didn't go into the details for reasoning. I know Jasper has a reasoning engine, but in our case, we have that reasoning layer, but all supported by the large language model on the line. So I feel like you can also have your rule-based model there or narrow model to support this process. And I think maybe the evaluators could be helpful here, like to check the reasoning, whether it makes sense. Is it ethical enough, aligned with the standard? I guess some checks could be there.
Right, so you're looking at the reasoning from the outside and the reasoning itself, or how you impose machine intelligence or machine rationality there is not part of the core.
I think the reasoning, our architecture just try to show, like, before doing the planning, we need to ask or get a large language model to think about the process, like which could be the way to address the queries or address the problems from the humans. So that's, I think it's like internal reasoning process of the agent. You can see large language model reasoning.
Oh, thanks. Any other questions? We'll go to the back there.
Hi, thanks. This is maybe going to be a kind of negative sounding question, but I'm just genuinely curious about it. Dr. Karimi, the thing that stood out most today was when you were talking about the evaluations of LLM summaries, they actually sounded not that great. There was a high level of hallucinations. And so given that we know that that's the case, how can we use these tools for science? It seems like that's an important problem.
Yes, we had to evaluate which ones are more reliable, at least for our use cases. Not all of them are highly. I mean, depending on how much abstractive you get it to be, it becomes more hallucinated. So maybe, yeah, somewhere in between. But
But practically now, like if I go on Notebook LM and I put in papers for area that I don't know about, and so I'm not able to tell if the information is true or not, like how can I use it?
Jasper tells us it's good. We haven't tested Notebook LM. But
Yeah, if you go to Notebook AM, so then Savnas mentioned citation is super important. So then you can say you got all the inline citation. Also, behind the scene, if you're making an API call to Gemini API, it's also give you the citation score number. So how grounded this particular response? It's give you the response about the summary, but also give you for each piece of the summary, it's linked to the reference contents. And also for each of the reference contents, it gives you a score of 0.6, 0.8. Then you can decide fully flexible for you to decide how reliable this response is. But in general, if you don't do any customization, the response will have a built-in citation for each of the reference document where this piece of sentence is based on.
Can I actually be a bit facetious here? Like, how did you actually compare with a PhD student as an expert? Like, I'm just curious, like, because we're talking about in a research group, or like you're not having the people who are doing this kind of work are not always like the world's best experts. So I'm just curious on how an LLM compares to an average PhD student. No offense to any PhD students in here.
Well, the PhD students do a good job, right? But it's depends on what you want, right? So it's all those dimensions. You want it to be a really well readable summary, and how much of the depth of the content you really want, then that changes so much, right? In terms of evaluations. Yeah. So we had some in these papers that we published. We didn't put all our experiments. We tested more than 7 LLMs, but then some of them were like literally just more like on the extractive. So they would copy paste lots of content and then put them together, which I suppose a lot of maybe more junior level PhD would do to put it as the summary. So that's all correct, but is it what you want?
Yeah, just to add up to Savnas just mentioned, I recently listened to a podcast, DeepMind podcast, talking about AI for science. I think Demis is the DeepMind head. So he mentioned that the major difference between a Gen AI agent and a human is that for scientists, in particular for PhD or for a doctor, the really unique value is that he or she knows how to ask the right question. So that's the fundamental how human actually proceed, right? Progress over the hundreds of years. But Gen AI, at least for the moment, don't know how to ask the question yet. I don't know whether one day that will come or not, but at least that's a big difference. Just back to your question. So for a doctor or PhD, he knows how to, or at least he is getting better and better about asking right questions. But Gen AI is far away from there at this moment.
We'll go one more question from the room, and then we'll go to the submitted questions.
I run a startup company that is using AI for uncovering secrets in chemistry. I'm just curious, besides being a customer of Google, as a user of the different tools, does Google or maybe even CSIRO, do you guys offer any opportunities to collaborate? Obviously, we're very commercial facing, but on the foundational side of things, we could always use help. Just curious to see if there's any opportunities to work on different projects that we have from, I guess, customers.
Let's probably have a chat afterwards, because this how long is a piece of string kind of question. There's a whole bunch of startup programs. That's one mode of engagement. We have the Digital Future Initiative, which is kind of specific projects, but there's criteria there. So let's have a chat afterwards, and there's quite a few different ways you can engage. I just better be respectful to the people who are dialing in. I'm afraid I've been trying to figure out how to present these questions, but I can't. Stefan dialed in yet? No, he hasn't. Okay, let's just go most popular questions. I'll read them out. Oh, there's an easy one. Will the slides be presented after the session? I can answer that question. Yes, they will be. Okay, with 12 votes. When working with machine learning models, how do you address the challenge of ensuring consistent and deterministic outputs for specific inputs, given the inherent unpredictability of the model's behavior after training? That's yeah.
I guess the simple answer is to reassess constantly, because that's what I was saying about it. 20% of the workflow has to be evaluation. You keep up re-evaluating, but you have to think about the methods of re-evaluating that doesn't include constantly a human evaluator in the loop, because we can't do it anymore. That's all I can say. But I missed the rest of it. Was it the
I think you've kind of got the basics. You might want to stay up for this next one. Here's a curly one. How are you taking account of copyright and licensing considerations in summarization engines?
Is that for me? I don't know. It's for our purposes, for our experiments.
Yeah, for your specific experiments.
Yeah,
I guess.
so we basically use all the papers that have we can use it. They're publicly available. That's why we went to PubMed Central, at least for our experiments. But yeah, I guess LLMs might have those papers embedded, and there's nothing we can, at least we can't do anything about that.
Yeah.
But
Oh,
if
I just very quickly add from Google Cloud perspective, Google Cloud GenAI service provide indemnity guarantee, where basically means that we provide two indemnity guarantee. One is we provide that for the training data we use. We're making sure we actually using the training is not breaching any IP. So if your other third party challenge you or sue you in the court about you using Google GenAI, then we will guarantee you we get it back, we protect you from the training data perspective. Also, we provide the indemnity guarantee for generated content. So again, in that particular case, so in a reasonable context, Google will protect you if you are challenged by other third party for generated content because of using Google GenAI services. I just want to add up. That's a more business part, not the theoretical part.
But I guess RAG is the way that we try to index what we can index and use that as opposed to go wild. Yeah.
Okay, next question. LLM generated summaries of, by the way, I've tried a few times to present these questions and I'm failing miserably, so I'm just going to keep reading them out. LLM generated summaries often end up generalizing to the point where the key takeaways are missing. How do you avoid this?
Yeah, so that goes with the prompting. With sometimes you want that very generic answers, and sometimes you don't want. So I guess you create the persona that you want. At least that's the way that I can think about. So you really you have to give them this personality that you are, or as generated for a scientist, for a specific scientist. And also the question focused summarization helps there as well, because it will answer the sort of questions that you want to be answered, as opposed to something generic like summarize this paper and on what exactly. You might not want like the introduction of the paper.
Thanks.
Yeah, I think prompting definitely is one way. The other point I want to add is the model behind Notebook LLM is particularly fine-tuned and also specialized in summary and answer questions. I would really keen, if you try, for the people who ask a question, if you try the Notebook LLM, really keen to understand your feedback about the accuracy and also spot on of the summary. Yeah, keen to know that. But from what I experienced so far, it's quite cool.
Thanks. Let's take one more question from the online question, and then we'll go back to the room. If there's any questions. Notebook LM, are there data volume limits? What would be the upload time for hundreds of gigabytes or terabytes of data? That's a Jasper question.
I need to double check, but my memory, I believe the up limit is 20 million words. That's a lot. So I think unless you, I don't know which domain you research on. Hopefully that's enough as a base to answer to do the research.
Actually, just on, I don't know the answer, but if you are interested in Notebook LM, you'll see Jasper mentioned that one of the core team members is Steve Johnson. He's actually going to do a talk for the GDG AI for Science in February next year. So if anyone's interested in a deep dive and hearing from one of the core team members, I'd encourage you to come to that talk, and you can ask lots of Notebook LM questions. Let's go back to the room. Yeah, question over here.
Something about the MedPalm LLM. How has it been the response from the research and the pharma and etc.?
Sorry.
What has been the response? Like, I mean, is it GA and how has it been so far?
That's mine.
MedPalm now is called MedLLM because behind the scene it's not Palm anymore. Palm is the previous generation of the model. Now the base model changed to Gemini. So it's MedLLM at the moment. In terms of the accessibility and the release list, it's already GA for US customers. But for customers outside the US, it's under preview. So if you are interested, you can reach out to Mel or myself. So we try to help you to get access to that. The reason for that is because the MedLLM is very deeply medical area where a lot of legal and medical regulation rules in place. Because of that, even though it satisfies all the requirements from US perspective, but may not fully matched with what regulatory requirement from Australia perspective. So that's why in Australia it's still under preview at the moment.
Any other questions in the room? This gentleman's been waiting for a while, so.
Thanks very much. My name's Paul McCarthy. I'm with a company called League of Scholars. We do data analytics consulting, but also we publish a magazine each year with the Australian about who's who in research. It's actually in today's newspaper in the Australian, for anyone who's interested. And we've done that for about 7 years in Australia now, and we use Google Scholar as our main source of data. So I was very interested to hear you say, Jasper, that you're very interested in a model that's grounded using Google Scholar. I think that's a fantastic idea and very exciting idea too. The question I had was actually about the first sort of thing that was said, which was the assumption that science hasn't changed. The scientific hypothesis and the scientific method is still the same. I just wonder if anyone else in the room agrees with that, or does everyone sort of agree with that? Because it seems to me one of the most interesting things that can be done is a sort of a no hypothesis exploration of ideas and using some of this technology to sort of move up the food chain and try and explore some of the questions, not just summarize sort of existing literature. And I think there's a guy in the front who's got a startup who sounds like he's doing a bit of this in chemistry as well already. So I'd be just interested in people's views on that.
Do you mean hypothesis generation?
Correct. Yeah.
Oh, hang on, wait for the mic. Otherwise, no one online will hear you. Oh, there we go.
I would think that this by itself does not change the scientific method. It does accelerate it immensely, but the scientific method still stands. But this is huge change, huge acceleration. But it doesn't, my view, the core of the scientific method, the ability to refute or to support hypothesis.
Anyone else want to offer a view on that? Max?
Just follow up on it. Actually, I wonder if applications will change. Like now we're using LLMs to write papers, and we use LLMs to read the papers. So why do we go through that step? I'm just curious if anybody thinking about both the future of, we're still not disseminating the research results. But is the current way of doing that, is that pretty much useless?
If anyone's interested in this stuff, there's the DeepMind team just hosted this big AI in science forum in London for a couple of days. But it's kind of a who's who of AI in science globally. You know, Nobel laureates here and there. Some of the videos are really amazing, and they start to get into some of these topics about, you know, are we just aiding the scientific method, or are we fundamentally changing it in different ways with some of these tools? So I would just encourage you to, I'll when we do the send out afterwards, I'll make sure that we include links to some of those materials.
Yeah. Last session I actually listened yesterday. It got 4 Nobel Prize winners on the stage. It's quite amazing. Yeah.
Let's go. We're nearly out of time. Let's go one more question online. Probably one for the CSIRO team here. Is it possible to store agents so they can be reused, so people don't reinvent agents for common functions, but can copy and improve? Actually, I'll give, there's a kind of a, do you want to give a general question and then we'll hand over to the CSIRO team, or general answer?
Well, as usual, I go to Google Cloud Service. We have a agent space coming very soon. Anyway, I probably let.
Yeah, we have seen many articles talking about some agent marketplace or agent repository, so you can find out the available agents in that database, and also the agent should be able to find the other agents. I think they think relevant to this task. So that's the idea of like different agents, they can work together, multi-agent scenarios.
Right.
We use now agents to find agents.
Agents to find agents. Look, that takes us to time, everyone. For those of you in the room, you're welcome to hang around, have another cup of coffee, and have a chat. I just posted everyone in the room who's not online yet. You'll get it when you get the feedback form after the follow-up email. But there's a survey that we would really appreciate if everyone could fill it out. It basically just assesses your kind of where you are at the moment in your use of LLM agents in science, and asks a couple of questions. But it'd be really valuable for the project team at CSIRO working on all of this stuff to get your responses. So I see a number of people who filled it out already. Other than that, Estitfa, tell me if I'm forgetting anything. The recording will be available. The slides will be available. Thank you very much for coming. Thank you all to the presenters as well. And for those of you that are in the room, Stefan, I see you just joined us again. We're just wrapping, and you're on mute.
Hear me now?
Yeah, we need. Do you want to say goodbye?
I'm so sorry. Like, worst time ever for computer problems to occur. I think you're wrapping up right now. But if there were any questions, pressing questions, I don't know how you handle it, but I would.
Yeah. All good. I think we got through them. But if there's anything else, we can take them on notice over email. For those of you in the building here in Sydney, the security team gets very antsy about people wandering around the corridors. So there are toilets just out to the right, but please don't go beyond that and explore, because the security guard will probably come and nab you and then me. So stay in the room, or duck to the bathrooms, and then between us we can show you down when you're ready to leave. Thanks, everyone. Cheers. Bye.